So this is the part that I really enjoy, your system design, all right, because a lot of people get confused on this process. And so we're going to start this off with just a real simple thing, okay? So we're going to divide up into 3 groups. We got 3 boards, 3 groups, and we're going to do a simple design thing. I'm going to give you 10 minutes to do something, and then we're going to talk about what you did, and then I'm going to start my lecture, and I think it will make sense. So let's number off. Okay, so as you move into your groups, all right, so this is going to be a project that you're going to do, right? All right, you're going to design a business card holder for me. I know, like, wow, cool, we actually get to design something, right? So you're going to design a business card holder. So what I want you to do over the next 7-8 minutes is talk about how you're going to do that. All right, and you might also talk about what are some of the things that we're going to incorporate into this. All right, and go.
Yeah, or like 1 point.
As long as someone can talk about it.
Yeah, like just enough to hold it, but not.
All right, so this was very purposeful and vague, right?
Yes.
So Duncan had the magic bullet there, right? Shouldn't we like interview people and find out what it is exactly what they need or want? Yeah. Okay. So how many people have been involved in designing something somewhere along the line? Probably most of us have at some point in time or another, right? Because you have group projects and stuff. Is this how most of them start out? You just start out and like, hey, okay, so we got to do this, and let's just do it, right? Am I right, or do we have a more involved process? Okay, so yeah, to do it right, we have to have a framework, right? We have to have a structure to follow. All right, we have to have something that identifies what it is that we're trying to do. Otherwise, so we've got people back here drawing stuff. And notice that, you know, his shirt says different. All right. So let's talk about this group. What was going on?
We just did a lot of design until Duncan came up with that genius idea.
Okay. So we just jumped in. We're starting to build things. All right. So, okay. How about over here?
We kind of start talking about what the different designs, but also functionality, and then discuss different mediums, which we're on the same page.
Okay. So you at least did ask, you know, hey, is this something that goes in your pocket or sits on your desk? All right. And back here, what did you guys do?
We talked about what kind of material we're going to use, what it needed to like do in terms of like how much it needed to hold. Is it the normal size of a business card?
What if my business card's like this?
Exactly.
Then you need to
We said normal.
All right. So keep this in mind because this is actually going to be an assignment, right? It's going to be a group assignment in that you develop and design a business card holder for me. Ooh, for me. Yeah, I'm not liking that. It's too plain. Oh.
It's got a little slip in. And groupies. You can make it multicolored.
Okay. All right. So let's see. All right, so the design process, all right, and
Can we move back to our seats yet?
yes, you can move back to your seat. I'm sorry, I forgot, you're sitting next to people you don't like.
Yeah, get out of here.
More important, you're not sitting with my notes.
All right. So the major components of the system design process is definition, okay, defining what it is that we're actually trying to do, analysis, all right, figuring out is this the right way to do it, design, creating that thing, right? All right. Once we've got a design, then we're actually going to make it, and then we've got to do some testing, right, to make sure that it actually conforms to all these things that we want it to do. So a lot of times when people are thrown into a project where they have to create something from nothing, all right, they get started right here, all right. And so what do we have? We've got a drawing back here. We had a drawing over here, all right. So you guys proved out right there, okay. One of the things that I notice a lot with our junior and senior engineers is that that's exactly what they do, all right? And not only do they start on a design, but they'll narrow in, right, and they'll focus on one little nugget of that design, and they'll get it, and they'll work on it, and I mean, they'll put a whole lot of effort into it, and then bam, they got that. And then they start to step out back and be like, oh, wait a second, how's that going to work in the overall design, right? So they've got the cart before the horse, right? And I see this every year. Every single year I see this very same thing, right? And it's frustrating to me because I'm a systems guy. This is what I do, all right? Unfortunately, our instructors, our faculty on the engineering side are not systems folks for the most part. And so they focus real heavily on this design portion of it, right? But if they actually applied a little bit of systems thinking to this, they could have a design that's much more functional with a whole lot less heartache. Because what happens is that they're married to this one little part that they made, right? And then as they step back up and they look at the things that it interacts with, and then they start trying to make those things fit this, right? And then they take another step out, and now they're trying to make all these things work together, and it literally will drive them crazy. They engineer themselves into a corner, all right? And so then they're spending a whole lot of effort trying to figure out how to solve multiple issues, all right, because they started down at that micro level instead of at the macro level. Does that make sense to everybody? All right. You're going to see this no matter where you go. You are going to see this happen, all right? And like I said, here we shouldn't, but we do. And I've had countless discussions with our engineering faculty, like, hey, there's a better way to go about this, all right? But again, they're stuck on what they do. They do design stuff. They don't really think about the whole system stuff. All right. So you will see this. I promise you'll see it a lot. All right, Henry Ford. Nearly all of these features, talking about the gasoline buggy, Model A Ford, have been planned in advance. That is the way I've always worked. I draw a plan and work out every detail on that plan before starting to build. For otherwise, one will waste a great deal of time in makeshifts as the work goes on. All right? Man, the father of the industrial assembly line, and it's still true today. All right? And so what he's talking about is we're starting at that macro level, right? And we're looking at the system as an overall thing, all right? And then what he does is he picks out all those major components and what they're going to do, what the inputs and the outputs are going to be, right? And then he steps in a level and he starts looking at those and see how they're going to interact and what specific things they must do, what functions they must accomplish, right? And then he steps in another level, right, and does this. So if you do it from the macro down, all right, you already know what you're going to get out of it. If you start from the micro level, you focus in on one little spot, all right, and then start zooming out, invariably you're going to run into problems. Right? So anyhow, I think that's wonderful. I really ought to put that as my screensaver. All right, so as Duncan so eloquently put it, shouldn't we interview somebody? All right, the very first step is we have to understand the problem. We have to define what it is that the problem is. All right? So we have to talk to the people involved. All right? We have to talk to the customer. We have to ask them what it is that they need and then what they want. All right? If there are constraints involved, i.e. it can only cost X amount of dollars or it must fit within this type of envelope, all right, then we need to understand those right up front, because if we talk to a customer who wants a business card holder design, right, and then we don't clarify what that business card is, all right, and we design something and then we find out that the business card is not 3 by 5, is not, I don't know, what the heck is the normal size?
Whatever the wall size.
I don't know, that big. That big. And then we find out that, you know, they're so important that they use one that's this big. What happened to our design? It doesn't work, right? Now we might be able to scale it up, but in essence what we've done is we've put a whole lot of effort into something that doesn't meet the requirements that the customer has had from the beginning. All right? Cause and effect relationships, we're looking for those early on. And again, who is the source for this? Who is going to give us the most information? The customer, right? Because they're the one who has already identified that, hey, I have this need. Now, does the customer fully understand everything that they need? No, very rarely do they. Sometimes they do, but usually not. All right, and so we have to ask probing questions, all right, to gain a really full and thorough understanding of what it is that they actually do need. All right. We had the, in one of the slides there, right, it talked about the little swing set thing, right? It had 5 different slides and everybody's different perception of what the swing set should be. Do y'all remember that? I guess some yes, some no, and there's a couple people that I think are about to go to sleep. All right, so we have to make sure that we're talking in the same language. We're going to talk to the customer in the same language that they use. We're going to use the same type of slang that they use, all right? Because every industry has their own language that goes along with it. So my main component is I work on designing projects, right, and bringing those to completion. So I deal in measurements of 1/1000th of an inch, and so I talk about thousandths, and I've had people come in and be like, wait a minute, tenths, hundredths, what? What's 1/1000th? What are we talking about, right? Because they didn't understand what it is that I'm trying to do. I say a tenth, all right? A tenth is a tenth of 1/1000th, so it's 10/1000ths, all right? It's a very, very small measurement, all right? But if we're not speaking the same language, then we're not going to get what it is that we want. All right, so high-level requirements, all right? So these are the things that it must absolutely do, all right? What is it that it must absolutely do? Are there constraints that go along with it that we have to be aware of? Where else can we gather information about this? So I asked you to design a business card holder. What would you do next?
You can look at like other business card holders that already existed and see how to make them better.
Okay, yes. What else?
I was gonna say, like, you can go to places like Vistaprint and see what the average size they sell is.
Right. Okay, so I can start gathering some industry-specific knowledge too, right? So once my customer contacts me and we have an initial discussion about what it is that they want, right, I can start gathering some background information, all right, that will help me prepare for when I talk to my customer, right? So I can start getting an idea of the verbiage that they're going to use, measurement types that they use, all right? So if they are using metric as opposed to imperial units, something very important, right? I want to know all that stuff right up front so that when I actually do have a chance to sit down with my customer, we can get as much done as possible. All right? So we can look at the industry. Google is your friend. So one of the things that happens a lot is that somebody comes to us with a problem, and so had Isaac Wickham was just in here with some parts for his airplane, right? And so very first thing I did is like, oh yeah, well we could do this, all right? What did I not do? I didn't get all the information that I needed from him right up front. I just immediately said, oh, well we could do this, or we could do this, or we could do this, right? But I didn't gather enough information to actually give salient points, and so literally wasted half of that conversation because I didn't fully understand what it was he was trying to do. All right? And so I should have been like, okay, so how big is the motor? Is there a weight constraint? Is there a strength constraint? All right? Those are questions that I should have asked right up front, but instead I just started throwing out solutions right off the whip stitch, right? We all tend to do it, and we have to override that desire to say, oh, I know exactly what you need, because you probably don't. You might think that you do, but you don't. The easy thing is to do what has been done before. All right, this is a two-edged sword. What does that mean? What does it mean to you?
The left one?
Easy thing to do is what has been done before.
That you don't have to think about it just because other people have already come up with it.
Okay.
You don't have to written.
Okay.
You can use existing resources.
You can what?
You can reuse or repurpose like existing resources.
Okay. What else? Matt?
The market's probably already filled with what you want to put out there, so you want to differentiate yourself a little bit more.
Okay. What else? So it's a two-edged sword, right? What's the cutting edge of this?
It's really hard to get people to buy your product because it's already there.
Okay. So the easy thing to do is I can already look at what's been done, right? And so that's easy. I can look at what's already been done, and then I can copy that. All right. The downside of that is what?
It's already been done.
I'm doing the same thing that everybody else is doing, and so now I need to do something else to differentiate what I'm doing. All right. The other side of this is that if I step back and I look at things objectively, right, instead of subjectively, and I try to gather as much information as possible, I can make something that truly addresses everything that my client needs. All right. So this is kind of a little divergent thing, right? In that I can, if I don't want to spend a whole lot of effort and resources on something, I can just look at what's been done before, all right, and look at those, and I can take things from those, right, because they're already working, right? Or, okay, I can step back and I can just go through the whole process, all right, and pull out the actual requirements that my customer wants or needs, all right? But, so this is why big companies find it hard to change. Yeah, I mean, you're going to find it hard. Change is difficult. Nobody likes change, all right? So we're all sitting in different seats, right? And nobody likes change. Nobody likes change. I don't like change. All right? But sometimes we have to change in order to do innovative things.
I'm going to,
Oops, that's not what I wanted to do. This is kind of cool. This is the auto-driving Tesla. We're going to watch about 2 minutes of this. I'll have to edit that out.
control where you can actually take your hands off the wheel.
Yes. There are some that have, there's actually some that actually do auto parking. You do have that, what do they call that, lane departure assistance, where you basically can just let it do its thing on the high-end models. And it's going to get better and better. You know, there's going to be more functionality that comes into it, but still, a lot of things that they have to look at to make these so that, you know, they're 100% safe. And are they ever going to get them to be 100% safe? No, because human beings are pretty stupid people, right? They're stupid creatures. We do things without any rational thought. We do things that nobody else would think about. And so, you know, it's hard to take into account all the things that, you know, the human being can do or will do for no reason. All right. So this is just kind of, and this is from Delphi, who's kind of working on all the technology side of this. So here's all the different subsystems that go into this self-driving car. And actually this isn't all of them, these are the major components, right? So we got side radars, driver state sensing, side view cameras, side radars, rear view cam, more side radar. We've got connectivity. I don't know what the V2V, V2X is. We've got a controller system that actually brings it all together. Side view cam, another side, LiDAR, front cameras, front radar. All right, what's not shown on here? These are just sensors, right? That's all that we're seeing here is sensors, a communication unit, and a control unit. So we got a Raspberry Pi right here, and then everything else is just like the camera that we hooked up the other day, right? What's not shown?
Oh, sorry, it's not that, but V2V might be vehicle to vehicle,
I believe you're correct.
actually.
That would make sense.
Just like the different functions of the car, like the engine, the gas, and the
Okay,
gas and brakes.
Jared?
All the ways that the car reacts because of what's shown on the sensor.
Right. Yeah, so all this is showing is the sensors. It's not showing any of the subsystems that does steering, braking, acceleration, matching the speed of the car in front, accident avoidance, none of that stuff, okay? So this is really the tip of the iceberg. This is just a bunch of sensors, all right, with a control unit, and then comms, communication, all right? So we've got some other stuff here from Delphi as well. So they talk about their systems common processes. And so what they're looking at is they're going to outline what the requirements are. All right. So what would be some of the requirements? What would be some of the top level requirements? And we're going to flesh out that word top level later on. What are some requirements that would be required of this car?
I mean, reliability is important, and the system will generally function.
Okay.
At least that it won't fail catastrophically.
All right. So one, we can't run over anybody, right? That's number one.
So to do that, we gotta test a lot of them, and we want to crash a lot of them.
Yeah, we're going to definitely do a lot of testing, and there's going to be a lot of failures. All right. What other requirements are there? Is this thing autonomous? It has an autonomous state, right? So that the driver, once it engages it, it's doing its thing, right? So we have to be able to toggle in and out of that, right? What other requirements might we have for this system? So you're getting ready to buy this thing, right? What is it that you must have if you're going to buy this?
Money.
Yeah, you're going to have a lot of money. Jared?
And this might be different than what you're saying right now, but like at a certain point, an automatic car is gonna have a decision of who they protect. Like if they're in a hard situation on the road, like do they protect the pedestrian that's in front of you, or do they protect you in the car, or like other things? So like
Okay, yeah.
they have
So
to be able to know what.
so yeah, there's going to be a stratified, you know, in a no-win situation, we're gonna hit something. Do we hit the person?
Yeah.
Do we hit the car next to us? Or do we hit the telephone pole? All right? There has to be that matrix, right? And then there has to be a decision matrix for that. And then we also have to do what? We've got to make the program, actually, I thought I had the other slide up. We have to make a program, right, that does all that. Right? Who had their hand up?
And then is the driver or the company liable for when somebody is killed, whatever happens?
Yeah, there'd be a lot of, you know, what's the legalese of this? Who's responsible? Yeah. Good.
How could it handle different surfaces like ice and dirt, gravel and stuff?
Okay. So it has to be able to adapt to changing conditions, right? So when it's slick out, we're going to have what? We're going to have the little limited slip thing, right? Probably if you have a newer car, it already has it. You hit a soft patch, what's it do? It beep, 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 beep. And then the wheels kind of go soft. Actually, the wheels don't go soft, but what it's doing is basically it's removing power to that wheel, all right? Hopefully keeping you from losing control, all right? What other requirements might we have?
You get it approved by the government, that way you can actually.
Oh, yeah. We've got to look at the regulatory guidance, right? Because I'm sure that within our federal code, there's a whole lot of stuff that says, hey, on interstate travel, you must do this, this, and this. All right? And then if we're going someplace else like California, which California has a law for every single thing in the world, all right? All right, we have to make sure that we're able to conform to those, or if we're not able to conform to those, then we have to get what? An exception to policy, so that we can continue developing and testing our thing. Did you have something to say?
I guess redundancies of the system. So can the whole system function if one of those sensors is like obscured
Right.
for some reason?
What happens when one goes out? Exactly. So, you know, on my truck, I've talked about the automatic headlight thing, right? Well, if there's ice on the hood of my truck, it totally just, it doesn't work. All I have is dim lights, all right? And it'll say that the sensor's not working, all right? Redundancy, what happens if a particular sensor is out? All right, so if one of these sensors is out, does it just totally not do auto driving? Well, what happens if we're auto driving and a sensor goes out? Right? Okay, so these are the types of things that we want to look at. Big picture, you know, right off the whip stitch, what are the major requirements that we require from this, right? Safety is going to be the top one, all right? And then as we start building down in there, it's going to get more and more convoluted. All right, let's see. So there's systems common process, and these are just ideals that they look at as they're going through the system design process, right? So if something meets a goal, then we follow it, right? If not, we make changes to it. Capture all requirements clearly. All right, and you notice they've got all highlighted. So how much time are they spending on the front end before they do something? All right? How many hundreds of thousands of hours do they have devoted to this auto-driving car before they ever built the first concept? A lot. All right, I can't even probably count that high. All right, requirements drive implementation. We're going to talk about the V diagram probably Wednesday, if not Wednesday, Friday. All right, and so you're going to see that in real life. Verify all requirements are met. All right, so this V diagram I'll talk about, actually I've shown it once before. So basically it looks at, we start at macro and we start stepping it down, breaking down things smaller and smaller and smaller and smaller until we get to that smallest level, right? So those are all our requirements. Then as we start to design, okay, we're addressing all of those, right? And we're testing at the component level, and then we go up to the subcomponent level, and then we step up, and I just hit 10,000 steps standing here. Anyhow, so then when we get back to the top of the V, all right, we're all the way back out to systems level, and all the components below have been tested, all the subcomponents have been tested, all right? So the V diagram really, really useful. If you understand the spirit of SCP, the mechanics become tools rather than burdens. All right, so a lot of times we think about, these requirements as very difficult things. Well, they should be difficult, right? Because making something new and innovative should be a difficult process. All right. Future of it, more emphasis on system design, closer integration with software and other standard processes, higher standard to meet increased customer expectations. So as they get the first cars out there that are actually functional, what are they going to do? They're going to add more things to it. They're going to add more bells and whistles to it, all right? Because the customer is going to expect that. All right, half of you are going to sleep. We'll call it a day.